Hello, everyone.
Hello.
Hello.
If you don't mind, we are going to give a few minutes to other people to join us, okay? Just 2-3 minutes.
Works fine for me.
Thank you. I believe we may start now. In last Saturday, we did this problem, and this is part of your homework assignment. And in this one, it is multiplexer, and I'm choosing input to come from line 0 or line 1, depending on the value of S. Then we moved to this configuration. It is similar, but here I have 3 inputs. 3 inputs. So in this case, I need 2 selectors. The 2 selector, of course, I can have one selector that is 10 input, but just assuming that I have just 2 input selector, I can use this configuration to achieve 3 input selector. In this case, I need 2 inputs, that is for the multiplexer 1 and 2. Today, you are gonna learn how to use process. Process, it is a little function that will be executed, and there is a triggering or a condition for the execution. That is the sensitivity list. The sensitivity list, for example, it can include the clock. If I have a clock rising edge or a falling edge, I will do certain tasks. The sensitivity lists are normally real hardware. Interrupt, for example, it can be real hardware. Enable, reset, clock. Those are real inputs, and I declare them in my entity, and I'm using them in this process. Let's see a good example. We have something called D flip-flop. As you have seen it before in Digital 2, D flip-flop, it has an input D and output Q. Q follows D. Whatever the input here on D, it will be reflected on Q. This is Q bar, this is the inverse of Q. So I have Q and its inverse. In addition, this is the symbol of a clock. The output will follow the input upon receiving, for example, a rising edge or a falling edge clock. Let's see how we can program it. Library, package, entity. As you can see here, I have 2 inputs, D and clock. And I have 1 output, Q. And this is my architecture of my entity, D flip-flop. Here, this is our first time to see the process. This is the beginning of the process, and the process, the sensitivity list, it is clock. The main triggering for this process is the clock. If rising edge clock, then D will go to Q, or Q will receive D. And if, don't forget, end process. I could have used falling edge. Both are available, rising edge or falling edge. The process, as we said, it depends on the clock. So the clock is on the sensitivity list. Now I'll give you 10-15 minutes to do this one. D flip-flop. Go ahead, please. I'll stop sharing and I will let you share the screen if you need any help. You can speak with anyone. You can post whatever error you have and let everyone learn and discuss this. Thank you.
These are all the notes, right?
Let me get back. Yes, this is my notes, slide 28.
Thank you.
You want me to keep it, but I wanted you to share the screen. Just go and you're going to find it on my notes, slide 28.
Well, I see in the example that we're not listing the inverse of Q as an output. And I guess, that makes sense. Well, I'm just wondering if there's ever a scenario, like if we're describing a physical circuit, if that actual not Q pin is going to a different input somewhere, in that case, would we want to list it, or we can just always just call not Q?
It is not Q. The other output, it is not Q, always.
Okay.
Is there anyone who needs more time?
I'm compiling now just to make sure it works.
Okay. Would you like to share the screen?
Yeah, I can.
Would you all please look at this one and tell us if you can see any error?
That last semicolon after Q out standard logic, get rid of that semicolon.
Yeah.
Can you see any other errors before we proceed?
Let's see.
The else if should be an end if.
What's it?
Yeah, it's and if.
Not else if. Excellent. Now you work on the waveform. Is there anybody who wants to show his program while Cody is doing the waveform? Okay. I believe here we have the first one is the clock. You can
Yep.
see, yes,
Oh, I was just gonna say, yeah, I got the clock for the first one set to 100 nanoseconds.
yeah.
And the
And
D-
you can see here the second clock, the first rising edge of the clock, we had 0, so the output is 0. The second rising edge of the second clock, we have high, so D went high. The third clock, D is low. That's why Q went low. Can you all recognize that? That's the waveform that you should all have. Thank you. Hello, Eric.
Hello there.
Do you have anything to share?
Yes, I do. Let's see, share. Here is, let me see, there's my code. Very similar to what the student was showing. And
Yeah.
then it compiled, and there's the waveforms that I got from it. So yeah, as
Okay.
it's showing, it will, the first rising edge, it will go high when the input's high, and over here, the output will go low when the input's low.
Excellent. Thank you.
Welcome.
Now we go to our next assignment. This is another D flip-flop. What this one is with what is called a synchronous clear or reset. What does it mean? It means that when clear is true, this pin is true, the output immediately goes to 0. It doesn't wait for clock or anything. That is asynchronous. How to do it? As we did before, but here I have clear. This is another input. Another input. And here is my process. I can see this process, it depends on the clock. And clear. Please note, clear is independent of the clock. Clock is independent of clear. That's why I have them both here on my process, my sensitivity list. If clear is high, then Q is 0. This is the first thing. The first thing is to check clear. If clear is high, output 0. Then else if, after checking clear and it is not high, okay, I'll go to the rising edge. Clock, rising edge, D will be Q. Please take a copy of the program you made, make another subfolder, and you can just copy and paste the program, then update. You need to update. All what you need to do is just add the clear and here put it in the process and make little modification, because we are gonna need all of those. Do not take it easy and just update whatever you have. Thank you. Please go ahead. Hello, Bart.
Yeah, I'm here.
Are you ready to share the screen?
I'm compiling it right now. I'm not sure if it worked. No, it didn't. I'll share the screen.
Okay.
Second. Desktop. Main window. I think this is it. Here we go. Can you see it?
We can see your MSI registration.
Oh, shoot. Just a sec. I don't use this computer a lot. Zoom. Stop sharing. Gotta make that a full screen, then I can do it. Okay. There, you can see it now.
You're good now.
All right, thanks, Cody.
No problem.
This is what I got so far.
Now let's read the error. It says object clock is used but not declared. What are those signals? The signals you are using.
D in, D out, and clock are the signals.
Do we have it in our program? The program I gave you, does it have it?
Yeah, it looks a lot more complicated than what we were doing.
Yeah, I might have done something wrong.
Would you please delete those three signals?
Okay, these ones here. All right, can you still see it?
Yeah.
All right.
You're working on the last one, not the asynchronous.
Oh, we're on 2. We passed that. We're what slide are we on?
We're working on the asynchronous, the very next one.
Oh, okay. Yeah, I was trying to add some stuff to the last one. I thought we were doing something different. My bad.
I was just curious because you need clear if you were working on that one.
Yeah, yeah, that explains it. Yeah, I gotta catch up. I'll stop sharing.
Okay.
Just to throw on the waveform, if you're working on the asynchronous, if you set the, oh, I hate this bar at the top. If you set the clear to kind of a weird time, you can see it turn off Q right in the middle of it with this little hump.
Hello, Joseph.
Yeah, I'm here.
Would you share the screen?
Yeah, you wanna see the waveform?
Yes.
Okay. Sure, here we go. Yeah,
Would you explain how is it related to the program?
oh, well, there's the clock at the top. I set it to every 50 nanoseconds. I put the clear at every 200. But I can see what, I think it was Cody that said, change it to a weird time. So, I mean, you could change it, I was thinking about changing it to like 155 or something weird, just to see it better. But then the D is, set to every 75. And then there's the output on the bottom. So, I mean, obviously you can see that this one did not turn on because it's, the clear is up. But, yeah, I was thinking about changing it to a different time so you can see it more clearly, I guess.
Uh,
Does that look good?
you're clear. Can you
Yeah.
see when it goes high?
Yeah,
The output went low immediately. It didn't wait for the rising edge of the clock.
Oh, I see what you're saying right here. This
Yes.
should have been long. Yeah, this should have been longer. Yeah.
Yeah,
Okay.
we call it
Yeah.
this asynchronous clear. Okay,
Uh-huh.
thank you.
Yeah, thanks. No problem.
Is there anyone who want to share the screen? Bart, have you fixed the program?
I'm working on it, getting it figured out.
Okay. We'll give you a few more minutes.
All right, my code's working. I haven't made the VFW yet.
Please share the screen.
I think you gotta change your viewing options to show a different window that's open.
Did you see it?
I saw it, but would you please bring it back?
Yeah, I put in a value for Q, so I didn't do Q right.
Yeah,
So it's
because
supposed to
here
generate
you are having the clear high. The clear is going high, but Q is high also. It didn't go to zero.
Yeah, I set Q. I was doing it kind of fast, so I set it with this. I don't know how to put it back to what it was.
You shouldn't be able to change Q. Q is output. You can only change the input. Would you get us to the program again?
Okay. Clear. Here's the code. Share. Here's my code.
On line 19, it should be if clear equals 1.
If clock, yes, clear, yes. Yes, recombine, please.
I don't want to save it as that.
Nothing else is jumping out at me at the moment. You'll have to switch your screen to, again too.
What were the numbers that you put them as? 100?
Let me check real quick. So first I set grid size to 20 nanoseconds. Yeah, under the edit. I put 400 for the end time. Of nanoseconds, yeah. Then I did clock at 20. Clear, I actually put at 150 because it'll show you some interesting stuff at the end. And then it looks like D is 40.
Okay, and then just compile it.
Yeah, then the functional simulation. So I set the clear to 150 because it happens right in the middle of when D is high, and it shows you that the asynchronous clear will force it low no matter what.
Okay. Does that look right to you guys? Can you see it, the results?
You gotta swap it again. It's showing us the
Okay.
queue with the queue hashed out. Or the
Thanks for your guys' patience. It's taken me a little bit longer to get the software up and running. I just had it going last night or a couple nights ago.
that's
can
actually
you
what I have.
That's what it looks like for you, Cody?
Yeah, so if you look at that second, when Q goes high the second time and immediately goes down, that's why I set the clear to a funky time.
Mhm. Okay,
Would you please track the clear and see how it affects the output?
you said do what to the clear?
Track your clear.
How do you
When
track?
it goes high, does the output go immediately low?
Yes,
Okay.
And it won't go high again until after the clear is finished.
Now we'll continue.
We're seeing your calendar. Okay. Yeah.
Another program. This is with synchronous reset. I am resetting the output to 0 upon receiving reset high. Similar to clear, but this is synchronous. What does it mean? It will reset the output to 0 upon the rising edge of the clock. So here, reset, it depends on the clock. D depends on the clock. That's why in my program, the sensitivity list, I have only clock. I don't have reset, because reset is dependent on the clock. That's the difference between asynchronous and synchronous. If it happens that you put reset on this sensitivity list, the program will run, but that is not a good practice, and it makes the program not easily readable and easily understood. Now let's go to the program. Now I have only the rising edge. When it happens, I start looking for reset. If reset is 1, Q is 0. Else F, Q will get D. Comparing this with the previous one, this is asynchronous. So I checked clear the first thing. Then I decided to go 0 or go to D. Here, my only sensitivity list parameter is clock. That's why I checked it. I check here the rising edge. If there is rising edge, I start checking the reset because the reset depends on the rising edge. Would you please do this program?
All right. That's what I got out of it. Hey, Dr. Wally, I have a question. I'm sharing screen. I had a question for you.
Okay.
Is there any way for like the reset line, to just choose a portion that's high instead of setting it on a time with the software? Like, could I draw a line, be like, I want it high here to here, and then drop back down?
Yeah, you
One thing that's
can.
been working for me is using the random. You can set it to a random value, then you can make it dependent on the interval or half intervals.
Okay.
But you
Because
only do that in your other window, since this is like the data window, it's already been compiled. But yeah,
Yeah,
that's how you
this
use
one's
random. It's
already
been very
compiled one.
useful for.
because I wanted to be able to draw my own so I could see the like what happens if it sits from here to here because it goes high and resets
Can you
off.
can you see the 0 and 1? The 0
they
and
should.
1. This is
That's
to
like-
set to 0 or 1 whenever you want.
Oh, okay, perfect. So I'll change it around for my own, but it's up and working.
Okay.
And you can see here that it's synchronous because it doesn't force it down when the reset goes up.
Oh yeah, you could highlight sections of the waveform and then just assign that 0 or 1. That's cool.
That's what I'll do. Thank you. I just found one other thing I was going to share. Let's see if I can get this up. So like I was talking about, if you want to do just one portion, it looks like you can actually highlight and then also use the 1-0 just to force that portion up.
Yeah, it's been asking and looking into that actually makes it very useful. I was using the random and would have to like reset it every few times, but until I got what I wanted.
Yeah, because I wanted a very specific behavior to show, right? So
Mhm.
you can do it that way.
Good looking out.
I believe we may move to the next assignment. This is a D flip-flop, and this D flip-flop is with enable. What is this enable? If enable is 1, this is a data selector. If enable is 1, D will go to the output. D will be here, and it will go to the output. What will happen if enable is 0? Whatever the output is, I will feed it back and get the same output. So output will not change if enable is low. If enable is high, I will get D. This is programmed in here. As you can see, I depend only on the clock. My process has only clock in the sensitivity list. That's in here. If rising edge, I check the enable. If enable is high, D will go to Q. Of course, the other option, if enable is low, nothing will happen, no change. Please go ahead and do this program. This is our last D flip-flop.
I think I might have it. Can I share my screen?
Please go ahead. Enable.
Yep. Does that look right to you?
Enable is here. Can you see the second rising edge?
No, I have to change my end time for that.
Yes, it is good. Just we are discussing it. If you look at the 90 nanosecond, the clock,
Okay, yep.
it is going up. And I have D high. And I have the enable going up. Should we get the output high or no?
So it needs to be high. Does
I
it
am
consider
asking.
Well, I was gonna ask if the software considers going up the same as a high signal.
It
Yeah.
has to go high on the rising edge.
Mhm.
So it would have to be high before 90 nanoseconds.
This is what is called setup time. For gating, I need my enable signal that is pending on the clock to be there before the clock. For the clock to acknowledge it, the enable signal should be there before the rising edge. Otherwise, it will miss it. And that is what is happening. Now, if you go and look at the 330 nanosecond. Yes, we have the enable, and upon the rising edge, I have also the D high, so I went high. Before the rising edge, everything is there. That is why it caught it and the output went high, because the enable is high well before the rising edge of the clock. Can you all see this?
Yeah.
Okay. Anyone want to share the screen? Hello, Paul? Paul,
Hello.
are you ready to share the screen?
No, I am behind because I didn't know I needed a new project for each D flip-flop. So I am 2 flip-flops back right now, but I'll be catching up soon.
Okay.
Here, I'll share my screen.
Okay, go ahead, please.
If I can find it. I think right one. No, that's not. Where'd it go? There we go.
Okay.
So like you were saying,
Yes, excellent. Very clear. Yep. Thank you, sir.
yep.
Now it is my turn to share the screen. This is homework one. Homework one. We together built the 8 input AND gate, MUX2, MUX3, D, flip-flop, all of those, we did them, and the inverter and the gates. Now we are about to go to the counter. This is my counter. It's counting 0, 1, 2, 3, 4, up to, I have 3-bit counter, so I can count up to 7. 0 to 7. After reaching 7, it goes back to 0 and keep on doing that. To do this, this is my program. It is a process. And this is for the first time I use something called signal. Let's see the program, then we speak about this signal. Rising edge, clock, and I have enable. I enable the counter to operate as we did it before. Counter will be counter +1. I increment the counter. Would you please notice this? This CNTR, it is on the left and on the right. Is it input or output? Brandon? Hello, Brandon? Hello, Joe?
Yeah, I'm here.
Is this counter input or output?
I would say it's neither. It's an internal signal, so it doesn't go in or out.
Yeah, that is what is meant by signal. Signal means internal. It can be input or output. That is why I used this signal to denote that this an internal wire. It is not connected to the outside world. Outside world, we have clock, we have enable, and our count, not counter, count. After each round, counter will go to count. Count is output. So it is always receiving whatever the status or the value stored in counter. This is very similar to a simple circuit we had it long time ago. This circuit. If you look at this circuit, can you see C? Is C input or output? It is output of the AND, but input to the AND, to the OR. So C could be a signal. So I can use C as a signal, especially in this version. Here C as an output receiving A and B. Then I am using C as input for E. In this case, C will be a signal. This is the program that we want to do. So please go ahead. And this is our last program for tonight. Slide 32.
Can anyone see this?
Did he explain why we're using behavioral instead of synth in architecture now?
No.
Okay, then I'll ask when he comes back around.
How is it going, Cody?
I had a question for you that,
Yes.
so in architecture, I'm sorry, if you're looking at the slide that we're working on, we usually do architecture synth of whatever the name is, and then the begin stuff. Why are we using behavioral now?
What? This is, for example, here. What is your question again? I have here my architecture.
Let me pull up your screen. Yeah, so line 15.
15, yes.
Architecture behavioral instead of synth. What's the difference?
No, you can give it any name.
Oh,
This is the name of the
So that name
architecture.
doesn't define anything. Yeah, I was reading about this earlier because I was confused too. But no, it's literally just a name that you give it. The entity name has to be defined, which we do earlier.
Mhm.
But really, it's kind of used as a readability thing about if you're doing, behavior or we were just synthesizing something, I guess, earlier. Another common one is RTL and different things, but it's really
But
just.
it doesn't actually matter. It's not
No,
a hard
no,
code.
yeah, I haven't tried it yet, but what I was reading earlier is you can name it whatever you want. It's just a.
Okay, that's all I was curious about.
So the key thing you have is the folder name, the project name,
Mhm.
the entity name should be the same.
Yes, that part I've been doing. I
Yeah.
didn't realize the word after architecture didn't matter what it
Yeah.
actually was.
Are you done with your program?
It just analyzed correctly, so I'm gonna set up the waveform.
Okay.
I'm getting an error with my code. Can someone take a look at it?
Okay, share the screen, please.
Take a peek. I just fixed a couple myself.
You gotta take
Something
the
to do with
reset out of the port.
Count needs to be standard logic vector. 2 down to 0.
Reset out of port.
Yeah, there's no reset on the counter.
Okay.
Oh, that too. Yeah,
This is,
that needs to be the exact same as counter, so that you can put one to the other.
which one did you say? I'm looking at the PowerPoint and it's
We don't have reset.
Yeah, no reset.
a reset. Okay,
Now there's no reset. You gotta take that out of the process at the bottom too.
wonder why'd I get this out of the PowerPoint? Where was it? Like, how's that look?
I think he's needed 2 and ifs still.
And
Oh,
your line 18 needs to have colon is equal to in quotation 000 and then semicolon.
At the end of the line.
Yeah, at the end of the line,
The very end,
right before the semicolon.
one more. Keep going. Just one more over. There you go. So just put colon with the 2 dots. There you go. Is equal to
like this.
just
Oh, just equal.
equal sign. In parentheses 000 end parentheses.
I must have been looking at the
Yeah,
wrong PowerPoint.
quotations, parentheses, same thing.
And then line 12 at the end of standard.
Just one,
logic
please, just one,
vector.
please. Do you know? This is to initialize your counter. I'm initializing the counter here to 000. And I use double quotes because I'm not using single digit. I'm using 3 digits. That's why I use double quotes, because I have a vector that is 3 elements. Now continue, please.
Yeah,
Okay,
your whole process area needs to be looked over because it doesn't match what this this counter is.
I can see
Yeah,
here also
you have the
there
wrong
is
PowerPoint slide.
counter others count. We have already initialized it to 0. You don't need this one. Line 24.
I think I have the wrong slide that I was taking it from.
Okay.
One more I caught, it's like line 11 or 12, where you have count out standard logic vector. You need to put that 2 down to 0 on it.
Okay. What slide were you guys getting that code from? I didn't see it in this.
You need to follow this code.
Slide 30.
Oh, Yeah, for some reason mine downloaded without this.
I've just been snipping as the professor is showing it, so that you just
Yeah,
keep along with it.
yeah, I got it now. I copied it.
It's on lecture week 1A, page 32.
Yours
Oh,
is
okay.
32?
All right, I was in lecture 2.
I've got page 3. I'll just pop in here. And there you go. I got my waveform up. So I left the enable down for the first clock cycle just to show that the enable cancels it, and then left it high for the rest of it to let it count. And if you take a look down at around the 360 nanosecond, you can see that this counter rolls over. It doesn't have an issue if it goes
Yes.
above specified bits.
Counting from 0 to 111, then going back to 0. Yes.
Yeah.
Excellent. Thank you.
No problem.
Anybody else who want to show it, who want to share the screen? Hello, Taylor.
All right. Can you see it?
Yep.
Shows it resets right there.
Yes. Thank you, sir. I believe that is all for tonight. Now we have only one last program, full adder, that we'll do on Saturday. Then we'll be starting our next topic, topic 2. Yes,
Adder
sir.
is on the homework that's due Thursday.
This Thursday?
Hold on, let me make sure I'm not wrong on my dates. I might be.
Mine says the 24th is
I'm
next
wrong.
Tuesday.
Never mind. I was off by a couple of days.
Okay.
We have the adder, but we also had 2 other things, didn't we?
I think we saw that, and where is it?
Trying to remember what they were.
Are we just using the ones that we did from last class? It wasn't quite the same.
We did all of those, including counter that we have just done. Only adder 8. This is the only one left.
I don't think we ever did the 4-bit wide inverter or gates.
Yeah, I didn't think so. Hold on.
Now I remember doing the 4-bit inverter.
I don't have a file for any of those.
Yeah, I don't remember doing that.
4-bit wide inverter, here's it.
Yeah, the inverter and gates. I don't
Okay.
think.
Even if I didn't do it during our lecture, it is very simple. You can do it.
Yeah.
Okay. So I believe all what is left for us is this adder 8. So please make sure that you are done and your file is ready. For each one, I need the code and a screenshot of the waveform. All of those will be in just one PDF file. On Saturday, we'll do the last one. You add it, submit, done. You did very well on lab 1, and I got it in time. That was great. I believe we can do the same thing for this homework one. I wish you all a good night and see you Saturday.
Thank you. Have a good night.
Thanks.
Thank you.
Have
Bye-bye.
a good evening.
Okay, bye-bye.